Hello and welcome everyone to today's workshop on building a MicroProfile application and running it in Verrazano's multi-cloud container management platform. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. We're excited to get hands-on with Helidon and Verrazzano and to show you how the software technology can help you with your existing projects. If you do not currently have an Oracle Cloud account, we've got a special promotion that I'll drop in the chat in just a moment so that you can try out the OCI services and follow along with the lab steps today. We'll also be recording this session, so if you'd like to complete the lab later on, we'll be sending the link to the recording via email shortly after the workshop concludes. If you have any questions during the lab, please ask them in the Slack channel and we'll answer them throughout the session. The link to join is bit.ly/join-devrel-slack. Once you're in, you'll land in the general channel, and from there you can search for #workshop-Verrazano-Helidon to reach our dedicated space for Q&A today. Today's lab will be presented by Maciej Gruska, Senior Director of Product Management, Enterprise Cloud Native Java. Special thanks to Ankit Pandey, Senior Product Manager for WebLogic Server, who will be helping out with answering questions today. So without further ado, I will turn it over to Maciej.
Thank you, Tara. Thanks. I hope you can hear me. Let me share my desktop. As been introduced, I work together with Ankit and the outbound product management team for Enterprise Cloud Native Java. This family of products in Oracle includes several application server technologies, but also includes two technologies that we will be talking today mainly. So we will be talking today about the Verrazano, that is a container management platform, and also Helidon, that is our Java microservice framework for building and running the microservices. One of the options what Helidon gives you is ability to run a MicroProfile applications that conform the MicroProfile specification. And I will be showing you today, and I hope you'll be experiencing. Also, the ability to build your first MicroProfile application with Helidon. We'll show you how to quickly start with the Helidon, and how quickly you have an ability to get familiar with technology of building microservices, collecting metrics on microservices, converting them to the Docker images, and plugging them into some kind of Kubernetes environment with a container management platform running on top of it. The laboratories that we will be running today with are expected to be run inside the Oracle Cloud. The tutorial that we have built are dedicated OCI. I will demonstrate step by step how to run the tutorials. I hope many of you would be able to follow after me. If you in any moment are lost, you may ask questions over chat. You may ask questions over a dedicated Slack channel. Ankit from my team is here to help you and to get you through as I will hopefully go. So let's talk a little bit what we'll be showing you today. Today, we will be presenting you the Helidon microservices framework. It's a lightweight, fast, and easy to use Java microservices framework. It has been built by Oracle Engineering. It has been fully open source. So if you go to helidon.io website, you will find out the access to this open source framework. It's gaining more and more traction and popularity on the development communities. We hope it's gonna get as popular as any other framework. We are providing a support for Helidon. We are doing it as a traditional open source frameworks are doing it through the community channels. We are providing a dedicated Slack channel for support. We are providing community support through the GitHub issues. Sources are being hosted on GitHub. So if you like to work with us and contribute to this project, we'd be more than happy to take this challenge with us. This framework is also supported commercially by Oracle. Oracle provides several commercial options for enterprise customers to take advantage of that framework and gain the commercial support. We are providing as well the integration of that framework with other Oracle technologies, like, for example, GraalVM. So we know that GraalVM is gaining a lot of popularity, and especially in the microservices area, when you look for a super fast startup of the containers and you look for super fast startup of the applications that provide for you microservices. The GraalVM is providing a super cool feature called the native image. So it converts the the bytecode of Java into executable environments that are natively executed with an operating system that is easily to be wrapped into the Docker container, that provides a super fast startup of Docker containers, especially in the environments of cloud, when you probably would like to provision some microservices on demand in a matter of a couple of milliseconds. Then the native image capabilities of GraalVM together with a Helidon that is optimized to take advantage of this native image probably seems to be very attractive. Helidon is coming with two development styles and framework. One of them we called SE. It's a very simple reactive programming model for building microservices. And second, that is confirming the MicroProfile implementation. We will be touching today the MicroProfile version of Helidon. We'll be generating MicroProfile application. I hope you will enjoy and you will see how easy it is to create a first microservice with Helidon that is running MicroProfile specification. So this is about Helidon. Verrazano is our container management platform for applications built on containers to run on top of Kubernetes. It's again open source project that Oracle contributes to the community. So developers are able to take advantage of Verrazano. Verrazano is like a complete opinionated, secure container platform that consists of several open source components like Istio, like Rancher, like Keycloak, like observability stack with OpenSearch, with Grafana, with Prometheus, and several other CNCF components. We have enriched that stack with several Oracle offered custom resource and controllers that simplifies creation and management of several type of workloads. And we are providing this set of components as a curated stack. So we are testing it together. We are ensuring that all of them are working together perfectly fine, and customers can take advantage of that complete stack of all those components as a one entity, as a one unity. The goal of Verrazano is to automate development and management, several types of applications on Kubernetes. We are very, of course, eager to help all our existing on-premise, non-containerized customers that are running our application workload on these technologies like WebLogic Server or Coherence, to speed up adoption of containers and to move and transfer the workload that they have been running for years inside VMs into the containers. Verrazano provides a set of abilities to convert that type of workloads into the containers and run them as containers in that complete opinionated stack. But Verrazano also gives you an ability to manage and control the deployment of new modern cloud-native microservices workloads. So if you build your microservices workload and you want to run them in the containers and you want to build and run like single observability for all your microservices that you have built, or you would like to plug them immediately into Istio, or you would like to provide for them a single security, the Verrazano is a potential attractive project where you can consider to run it. Verrazano runs on top of Kubernetes, but is a very Kubernetes agnostic. It can run on Kubernetes on-prem, it can run on Kubernetes in Oracle Cloud, it can run in Kubernetes in any other cloud. It is also multi-cluster, multi-cloud solution, so it can allow you to design management platform across more than one cluster. And Verrazano for multi-cloud, multi-cluster capabilities is probably like a very unique proposal to the market. So customers can take advantage of Verrazano and manage their workload, containerized workload across more than one Kubernetes cluster. Verrazano is offered as an open source solution, so you can take it, go to the verrazano.io page, find sources on GitHub, you can download it, run it, and as any kind of open source component, we attach to that very non-restrictive Apache license, so you are free to use, free to modify, free to embed, and so on. But we also distribute Verrazano with a commercial support. We give to our existing WebLogic customers a commercial support for Verrazano. We give an ability also for other non-WebLogic users to consider to run a commercial support on top of this open source project. So we believe Helidon and Verrazano is a powerful combination for running and managing microservices in a very modern cloud agnostic platform of Kubernetes, or vendor agnostic platform of Kubernetes, that allow you to run it anywhere, but allow you to achieve very similar experience of the common observability, single traffic management, single security layer for all your microservices, regardless where you run it. If you run them on-premise or in OCI, Oracle Cloud, or in third-party cloud, wherever Kubernetes platform is available. Today, during the labs, we will be providing you with an experience of running Verrazano on top of Oracle Cloud. That's very easy for us to provision it on top of Oracle managed Kubernetes service that we are providing as a part of our Oracle Cloud offering. However, if you would like to experience these labs on any other Kubernetes environment, it shouldn't be an issue to move it. We don't use any specific API that are Oracle Cloud centric. We don't use any special kind of tooling that are very Oracle Cloud centric. So if you'd like to experience the same experience with labs on third-party Kubernetes platform, feel free to test it, feel free to try it. It should really work. So how the lab should look like. If you go to the bit.ly/lab verrazano-helidon, you will get an access to probably this page. Oh, I'm getting access to control here from Zoom. Okay. Oh. So you will get an access to this page. This page is like a starting point for your today applications. We are hosting the tutorial for this labs on Oracle service called Live Labs. This labs allows you to experience the Verrazano and Helidon behavior on top of Oracle Cloud. So first, if you like to run it together with me, you would need to start with your free cloud trial. we have created promotion, and Tara created a link. I hope she can post it in the bit.ly. She just posted in the bit.ly a special promo for you, where you can request a free cloud trial to run this labs together with me. If you have any other cloud account that is like a commercial, you should be able to run it also there. We are not using any special set of resources from Oracle Cloud, except of managed Kubernetes environment and except of Oracle Container OCI registry. So the registry where we will be storing, pushing our Docker images with our MicroProfile application. So once you have the cloud account, in the first lab, we will be creating a managed Kubernetes environment. Managed Kubernetes environment, in our case, will span across 3 VMs. So we will create 3 VM fully mission critical or error-proven environment with the managed Kubernetes. These VMs will span across 3 availability domain within your data center. We will provision for you as a part of creation of managed Kubernetes environment load balancers. We will create for you a VCN network. So you will have an access to that managed Kubernetes environment through the kubectl interface. We will be using and experiencing kubectl today as a main interface of interacting with Kubernetes. This set of labs, or this lab today, is expected to be like a bring your own laptop. So we anticipate that major part of the development you will run within your laptop. So on your laptop, you will be developing your first MicroProfile application. It might be Windows, it might be Mac OS, it might be Linux laptop. What you need to have is JDK 11, and you need to have Apache Maven 3.6, plus Docker needs to be installed on your laptop before you begin. So the second part of the lab is you'll be running and you'll be building your Helidon application on your laptop. I will show you how to do that. I will also run it with you and for you, but I will be running it within kind of terminal inside the cloud. Oracle Cloud is coming with a service called Cloud Shell that allows you to open up like a very tiny VM with a terminal pre-configured with several set of utilities configured there. It is called Cloud Shell. Instead of laptop desktop during my demo on the recording that you are seeing or the demo that you're experiencing today, you will see I will be running in the Cloud Shell. The Cloud Shell version is slightly modified. It's slightly modified than the version with bring your own laptop or bring your desktop. Whenever time comes, I will ask Ankit to post the link to the Cloud Share version of the same tutorial into the chat or into the wiki, so you can run alternatively the second lab, not on your laptop, but also fully inside the Oracle Cloud. Once it is done, we will come back. Whenever we finish with creation of app, we'll come back to the cloud and we will check if Oracle Kubernetes engine cluster is fully created. And if yes, we initiate the Verrazano installation. So we will install on top of Kubernetes platform Verrazano. Then we come back to our laptop and we will package our application into the Docker container. We will create a Docker image with our application, and we will create a proper entry in OCIR, Oracle Cloud OCI repository for Docker images. We'll create an entry. We will push our image into the OCIR. So the lab 4 is about pushing pushing the image into the repository. When it is done, we will create as a Verrazano deployment a Helidon container. So we will create a Helidon application within a Kubernetes cluster as a Verrazano deployment, and we will experience within lab 6 what to do with this application, how you can find it on Grafana, how you can find it on Prometheus, how you can experience the log management to the OpenSearch, and how to see this deployment on Verrazano, and how potentially to manage the infrastructure to the rancher. So this is like an end-to-end scenario of our workshop. You will have an ability to run it on your own pace. You will have an ability to check it, how I'm running it as a part of the demo. I will generally follow the same guideline. Again, lab is available as a bit.ly/lab-verrazano-helidon. If you want to start it now. If you have a cloud account, you are good to go. If you don't have a cloud account and you would like to start it with me together, please go through the promo and provision your cloud account. It should be ready within a few minutes for you. So we will go exactly in this order. We will create Kubernetes cluster, develop locally Helidon application, install Verrazano, create a Docker image and push it. Based on that Docker image, we will deploy application to the Kubernetes cluster as a Verrazano deployment. And then we use Verrazano to access and monitor the applications. If you have any questions during the labs, please post them on the dedicated channel. I hope you had an access to that channel. That channel is monitored by Ankit from my team. He should be answering your questions all the time. If you have a question that is posted on the chat, he should answer that as well. So let's go. So what you should start with, oh, there's some chat questions. Oh no, that's only posting. Okay, so whenever you log in, how to start your lab? Okay, you have this page, you got this link. What you need to do is there is a button called Start, and the only option to run it is to run it in your own tenancy. So you need to execute that, and you get an access to the tutorial of that laboratories. So there are 6 laboratories that I have mentioned, organized on the left-hand side in the menu. So you need to execute them one by one, and I will execute them one by one, and I will show you how to run them. Generally, you need to execute them in the order. There are some possibilities that you may potentially come back and fix something in the previous labs, and they are not so much dependent, but it's general expectation that you execute them within an order. So first lab and first task is to create a Kubernetes cluster. To do that, when you log into your cloud tenancy that you have an access, this is the OCI console through which you navigate over different cloud services that Oracle offers. If you choose that menu in the top left corner, some people call it hamburger menu, you will find out services that are called developer services. If you select them, you will see a different set of services that we built for developers, different type of developers. I don't know, some developers that are very centric on Apex and database development. We have some services for API management. We have some application integration services. We have low-code services. We also provide different resources for developers, like Terraform ability to execute and orchestrate Terraform scripts and SAMP scripts. There are some content management services, but today we will be focusing on containers and services related with containers. To be very frank, we'll be using two of them. We'll be using Kubernetes cluster, that is nicknamed by us as OKE, and a container registry, that is our Docker registry in the cloud, where you'd be pushing your services. So let's start with the creation of Kubernetes cluster. To create a Kubernetes cluster, you need to select that option. You need to choose the compartment. Tutorial is showing you how to choose the proper compartment. If you have a trial account, basically you need to choose the compartment that is named root. But if you have like non-client, non-trial, or you're part of the big organization, you should choose the compartment when you have a right to create a cluster. So I will create a compartment here. I will create a cluster here, sorry. Let me move my Zoom control again because it disturbs me. Can I move it to my other screen? Sorry, I have a Zoom control here that really disturbs me. Okay, I will choose an option quick create. It will create for me all necessary resources, including VCN, internet gateway, service gateway, as well as Kubernetes Kubernetes master nodes and Kubernetes worker nodes. So let's call it, I don't know, hands-on lab cluster. Practically, you should choose any option default except of shape. If you go to the tutorial, you will find out that we are asking to choose a VM standard E4 flex as a shape of your Kubernetes node. The reason for that is Verrazano is provisioning quite substantial set of containers. So you get Istio, you get Prometheus, Grafana, Rancher, Keycloak, and several other containers. And these containers take some power and take some memory. So what we are asking to do is to choose this shape, as we have tested that shape is sufficient to run this configuration. So it is VM standard E4. This is the only option that you need to change. And we are also asking you, if you choose, to specify that you want to run 3 OCPUs and 48 GB of memory. It should fit into your trial environments. So, and number of nodes that we're gonna be creating is 3. So I'm specifying that, and I hit create cluster. This is asynchronous request for all necessary resources, and all requests have been completed. So you should see that my cluster right now is in the phase creating. We will leave this as it is, and we will move right now to the lab 2. Because we shouldn't wait and spend time on waiting until cluster is going to be moved to the phase ready. It is like a 15 minutes, 7 minutes, 7 minutes move to cluster to the active state, and 7 other minutes to make node available. So total time for creation a cluster fully functional is like 10 to 15 minutes. We don't need to spend that time waiting. We can jump to the lab 2. That lab 2 is based on developing Helidon application. Developing Helidon application, it is designed with that version of the lab to be run on your laptop. It shows you what you need to do and what you need to have in advance. So we require you to have in advance the Java 11 plus and Maven version 3.6.x. We highly suggest not to use version 3.8 there are some issues right now with this version of the lab with the Maven 3.8. So please do follow this prerequisites. Those of you who don't want to run it in the lab, we have created like a subversion of this tutorial. The subversion of tutorial is available on our private repository, where the lab 2 is slightly modified. The lab 2 includes creation the environment inside the Cloud Shell. So you don't need to, in that case, to really follow everything in the laptop. You don't need to set up anything on your laptop. If you want to keep your laptop free of any kind of Oracle or lab software, you may totally run it within your cloud environment with a Cloud Shell. We know that many developers would like to experience development on your private laptop, on your desktop, because that's usually how you experience with a software. So that's why the original version of laptop is of the tutorial is providing that capabilities. We know that some people that are coming to hands-on lab do not feel comfortable to install anything on their laptop. That's why we created that like a subversion of this tutorial that gives you ability to create an environment within a Cloud Shell. The labs are having exactly the same set of tasks, except of the first one, that within a Cloud Shell, we are creating one more step to install Java and install the Maven within a Cloud Shell. Cloud Shell is an environment that you have an access within your OCI console. On the top right-hand corner, there is a Cloud Shell button. And those of you who want to follow me with a Cloud Shell environment, we can click on that. If you're making it for a first time, it may take 3 to 5 minutes to create a VM for Cloud Shell. I was preparing for this lab, so in my case, the VM for Cloud Shell has been available, so that's why the access to terminal is giving me to relatively quickly. So I will follow the tutorial. First thing that I would like to run is to run this set of scripts. This set of scripts will install for me within a Cloud Shell the Maven and JDK and set properly path in my environment. So I'm executing that. If I right now make a Java-version, you'll see that I'm having in a path version 14 that is 11 plus. The same if I check with the Maven. So I follow that. So I have created Maven. I have created Java. The second thing, the second step is identical step comparing to the task 1 from the original tutorial. So if you follow here or here is absolutely identical experience. So you need to install Helidon command line interface. Command line interface from Helidon is like a simplified tool that is used to quickly help you generate project starters, to create a Maven POM XML files, and to quickly generate the infrastructure for your application. So I will install Helidon CLI within my environment. And then once it is ready, I'm ready to create my first MicroProfile application. I will use a Helidon CLI function, Helidon CLI interface, and I will use an option from Helidon CLI called init, and I will initialize creation of Helidon project. It will guide me through some set of questions that will generate, and at the end will generate for me all necessary files for that type of project. Okay, the first question is asking me what type of project I'm looking to create. Am I looking for a simple reactive framework of Helidon called Helidon SE, or I'm trying to build a micro-profile application with Helidon? And because we agreed that for today's tutorial, we will show you how to build a micro-profile application. So I will select option 2. And then there are several options of archetypes that might be generated. If you want to have a fully empty project with no default, I would say, implementation, like a full bare metal or totally naked micro-profile project, is option 2. There is a sample called Quick Start. It's a sample held on my MP project as an option that includes multiple REST operations. And then we have a Helidon microprofile application sample that uses JPA with in-memory H2 database. For simplification, I have selected for this tutorial a Quick Start application. So it's going to be like a project that has several already REST operation in it, and will let us use it as a good example to see how microprofile application works and behave within Helidon and later on within Verrazano. So I'm asking to create micro quick start application. Project name will be default, and all other, I think, options are gonna be default for me. He was asking me if I want to start development loop. Development loop is like a process that automatically compiles all the resources on a background for me. I'm not gonna use it. So my micro profile project has been created. There is a quick start MP. If I don't go there, you can see all resources are created here. There is Docker files, there are sources, there is POM XML, and everything is there by default. So we have some sample. We need to compile it and run it. And there is also a big change here, because within that terminal, I don't have, I would say, 2 terminal options. So I generally, if I want to run everything, I need to run it on a background. Otherwise, it will not give me ability to execute other commands. So if you run it on in your computer, you don't need to execute and run it in the background whenever you start Helidon application. But for cloud shell environment, you need to run it at the background to have an access to that application. So I generally execute that command. I need to probably come back to the top directory. Okay. So I'm packaging everything with Maven, and I'm compiling everything. As you see, Maven is gonna download all the Helidon repositories that are kept in a Maven, and I will execute my quick start application in the background. So my quick start application is there. Okay. And I'm ready to, so it started like a small HTTP handler with a netty HTTP service embedded. It has several REST endpoints by default implemented, and we will be able to test it, and it is running on the port 8080. So you have an ability to test it out through some curl commands to run some testing of that application. So for example, it has a greet endpoint available. And generally, if you make a call to that REST endpoint, it should return to you. It should return to you some hello world information. So it replied with a REST message with a hello world. That's default implementation. The greet parameter can allow you to pass as a REST parameter the name who's supposed to be greeted. So let's welcome Ankit on our tutorial. So it allowed me to welcome Ankit. It also allows me to another interface change the default greeting. So instead, so change a state of this RESTful service. So this RESTful service is keeping as a state information which way we should greet people. So if we change to the greeting RESTful service the state, and we change the value of the parameter greeting into the hola, then once we execute it once again, our greeting Ankit, we should get hola Ankit as a response. So service is running. Service is definitely running and is replying to requests that I have done. I hope some of you were able to do the same. What I would like you to point you is Helidon by default is collecting health and metric data. So every service that you build with the Helidon automatically collect all the health and metric data. It is part of the Helidon infrastructure. You don't need to do anything in your code to do that. Generally, health and metric data are available. We will take advantage of this functionality later on once we deploy it to Verrazano. So Verrazano automatically will be able to grab from Helidon all health and metric data. So you're able to collect it. So health interface is automatically always attached. Help REST endpoint is always attached to every service. So we collected the status of the Helidon service. I also can show you that you are able to collect metrics either in the Prometheus format or in JSON format, and they are automatically being exposed if on demand if you reach them by the REST interface. And Verrazano is taking advantage of that availability and is gonna query automatically for us our Helidon service to collect and persist the metric data into the Prometheus database. Okay, so application is running, application is available, application has been generated. If you run it on your laptop or your desktop, you have your first MicroProfile application with Helidon up and running. I will encourage you right now to stop it. So at this moment, you should stop it. In my case, I need to check the process and I need to kill it generally because it's running in the background. It is 4572 if I'm correct. Okay, we can verify and double check if I will try to execute a greeting. The local port 8080 is not available, connection refused. So I fully stopped my my application. That generally finishes the lab 2. And again, I was doing lab 2 from slightly different tutorial, but because I was doing in the Cloud Shell. If you run it from your original tutorial, it has exactly the same step. So it has a step about installing CLI, 3 different options depending what your environment is, creating greeting application, Helidon init, version MP quick start, and also the Helidon greeting, packaging, how to package it, the same way of testing, the same way of collecting metrics. And we will be right now going to this step called modify the application. So we will try right now create a new endpoint that provides a help for different greetings in different languages. So it's a dummy application, and we will make it even probably more dummier. So we will create like a new class that allows you to provide a greeting with multiple different languages automatically. So to do that, we need to create one class, and within that, I need to create that class. And to do that, I probably need to modify this this information by changing the username into username, how I'm logged into the Cloud Shell. In my case, it should be Ankit_x_PA. I will not code it fully. I will use sources that are provided here. Oh, sorry. I will use sources that are provided here. Let me go there. I will use sources that are provided here to do that. And the only thing that I need to modify is to put a package name. Ankit, could you help me here? What kind of package it should be? Ankit, you're here?
Yeah, you can take the help of a screenshot, which is same.
Excuse me?
Okay, okay, just a minute.
I think it was Ankit.x.mp, wasn't it?
Yes, it is package me.ankit.
Oh,
username.
it's me. Yeah, I can see it is here. So it is me dot. Oh, sorry. Me dot x pa dot
MP.
and dot mp dot quick start. Okay. Is it correct according to you?
Yes, it is correct.
Okay. So let's do. I have created some new class. Let me open it once again. This class will run on the all greetings RESTful interface. So path on which we will listen is going to be all greetings, and basically we'll be putting some information into the log. That's also very important action, because later on through Verrazano we'll be able to monitor and look for that log entry. So help requested is going to be visible in the logs that Verrazano is grabbing automatically to the open search interface, and we'll be returning the following array of strings. That's a very dummy interface. Okay, so I have created that class. I'm right now able to build it and run it again in the background. Okay. Okay, I should be right now ready to test this new functionality. If I perform operation like that, I will try to call the service with this new REST interface. I should get as an answer the array with this all those replies. That shows that the service is properly up and running with the new functionality. We can test again endpoints, and what we also need to do at the end is to kill the process. So I will stop it right now. Okay. So that concludes the application, the tutorial from the lab 2. We know what we are saying, but it should take 15 minutes. Really, if you go it quickly, it will take not more than 15 minutes. In my case, it took longer because I was trying to explain step by step what I am doing. So let's come back to the original tutorial and let's move to the next lab. If you remember, the next lab supposed to be installing Verrazano. So we should have already our Kubernetes cluster up and running. So you see my Kubernetes cluster has changed the status from creating into active. So cluster is running. We need to, in a first step, we need to have, if you go tutorial by one, we need to first step configure kubectl. To configure kubectl, there is a button here called access cluster. If you go to that access cluster, it will allow you to show you what kind of instruction you need to do to have an access to your environment. There are two options, and we ask you to take the one with a public endpoint. So this is option where we will be accessing Kubernetes cluster to the public endpoint. So I'm executing that. It will download for me kubeconfig environment, and it will collect for me a kubeconfig file. So if I right now execute kubectl, I don't know, get node, it should return me information that I'm connected to the clusters, which has been built 13 minutes ago, and it is running version 1.24.1. So it's really the cluster that I have just created. So I don't need to do it anymore. I will come back to my command line interface, and I will execute from that all my necessary operations. Okay, so this coming back, I have execute that. I execute information about kubectl get node. I receive information that my cluster has been created recently. It's running the version latest. So I'm ready to start. Sorry, I'm ready to start the installing Verrazano. To install Verrazano, there are, I would say, like a two-step installations. The first step installation is installing the platform operator. Platform operator give you an ability to control over custom resource that is demanding operator to install Verrazano in a proper profile. Verrazano is coming with 3 profiles. It's a production profile, development profile, and multi-cluster profile. So operator is like a small controller that will be running within a Kubernetes and will be checking if we demanded to start installation of a proper profile. So it's like a install controller. So we first think what we need to do is install that platform operator. Yeah, so operator request has been created. We need to believe, we need to check it out if the installation of operator has been fully rolled out. And we see that operator has been fully rolled out, and we need to confirm that there is a pod with Verrazano operator up and running. It should be in the running state. There is a question in a Slack. I believe MicroProfile uses JAX RS2 for statefuls, which is different than the mode sprite with the Spring, but I have two questions. Are there enough customers who are running MicroProfile with JAX RS in place of Spring REST for RESTful services? I don't know if there is enough, but we know that JAX RS2 is quite popular. It is part also of Jakarta EE specification, and Jakarta EE's community is pushing to get it as a default implementation for Java RESTful services as a standardized version. And we see significant adoption of that. So we also, and you are saying I'm attracted to JAX RS as it is started in the legacy Java EE application. Yeah, so we also see it, but this is like a very attractive path for existing Java EE developers / Jakarta EE developers to move into the microservices, because that's exactly the same API that is common across those two platforms. We know that some people are using another RESTful frameworks, especially Spring REST, that is very popular. However, the entire process of certification and standardization of MicroProfile that is also supported by Spring, it has selected JAX RS as an implementation. So it's hard for me to say it's enough customers. I hope it's an answer for a question. In the meantime, you can see that operator is up and running. So we are ready to install the profile. So once we have operator up and running, then we are ready to install the proper version of profile installations. So there are free profiles that you can select from. It's a dev profile, it's production profile, or is it is a multi-cluster profile. They're gonna install for you several different components. As I was saying, the platform itself consists of several open source components and several Oracle authored operator and custom resources, and some Oracle open source utilities. And every profile is having a different set and different number of this I would say, services itself. We will install the development profile, that is the lighter version, and it's probably the fastest in the installation. So we need to do that on OCI. It's very simple. It's just to execute such kind of command that is creating custom resource object of type Verrazano that is showing that profile parameter need to be equal def. An operator will look it, will find it, and will start the installation process. Installation takes 10 to 15 minutes to complete. We are not gonna wait it. We will move to the next exercise with it. So let's initiate the installation. Okay. It says that the custom resource has been created. So operator is right now starting the process of installation. And generally, we are not gonna right now test it and monitor. We will leave the Cloud Shell open, and we will check and verify if installation completed after the lab 4. Lab 4 is about creation and pushing the application image to OCIR. So we will need to package our our application into the Docker image. We need to test it that Docker image runs properly, and we need to push it to the OCIR. To push services to Oracle Cloud Container Registry, first we need to build it as a Docker image. To create a proper Docker image name, we need to have to know free information. We need to know in which region we are running, what is our tenancy name, and what is endpoint for our region that we'll be using. In our case, to find the region name, if you go to the OCI console, and this information, in this location, you find out what region you are running. My tenancy has been created with EMEA data center as a default location. So I'm using UK South. You may use US West, US North. You may use several other regions in this location. So important. In my case, it's UK South. Please note which one you are having. The second is you need to locate the tenancy namespace. To find tenancy namespace, you need to open developer services and container registry. So we need to go to our hamburger menu, open developer services, and go to the container registry. Container registry is a place what is a service that is used for storing your images, where you'll be storing your image, and then you need to select your compartment, and this strings identifies your namespace within a container registry. You generally need to copy this information and store it in some kind of text editor. So that's gonna be my tenancy name. Okay, and the third information that you need to collect is endpoint for your end region. The tutorial points you to the documentation where you need to find out what's going to be endpoint for your region. So there is a point in the documentation where it shows all regions that we have in Oracle Cloud. As you see, Oracle is right now having a very rich variety of different data centers where you can run your cloud infrastructure and cloud services. You need to find out your region, London South, and you need to copy the endpoint without HTTPS : // So that's going to be my endpoint for my region. So that's an endpoint for my region. And right now you need to construct the URL for your image. Construction of endpoint of a URL for your image should looks like that. We suggest to do that for that tutorial. I will copy it to the same place. So it should be endpoint for my region. So it is this part. Namespace of your tenancy. And then we also recommend here to use your first name here. Why we do that? It means some of you may be running this tutorial in the same tenancy, in the same account where your friend from your company is doing. So if you're sharing tenancy with, or sharing a cloud account with your friend, then you need to have here an unique image name. So to potentially solve these issues that you may be facing, in the tutorial, we embedded a solution how to run the same cloud account for more than one user. So how to share cloud accounts. So if you're sharing a cloud account, you generally need to put here your first name. So that's gonna be my image name, and I need to build in my cloud shell or in your desktop where you have built your environment. You need to build this image. And again, instead of image, you need to point here constructed URL for your image. Okay. So that's gonna be my I'm building my Docker image. I believe it should all be good. If you're running into the fresh environment, and we try to clean everything before this today demo, this may take some time because it's pulling some helper images and pulling some layers. As you know, this what you see, this downloading and pulling all these libraries from different Maven repository only happens because I'm having a totally fresh environment. In your dev laptop or desktop, potentially some of these layers might be already cached, and many of the steps might be much faster on your side. But what I'm demonstrating it here, build is right now successful. And right now I'm downloading OpenJDK 11, and it's going to be packaged into the image as well. Yep, and image was created. So if I right now run Docker images, I should see that image available here, that is ready for generally for pushing. So Docker image has been created. What we need to do right now is to take it and push it to the repository. To push it properly to the repository, we need to authenticate at the repository. our Docker interface is using OCI authentication token as a password. So what you need to do is to generate and create authentication token as part of your resource. So you need to, once you are in the OCIR, you need to find out profile. As a part of the profile, you need to find authentication tokens. I think I need to remove it, one of them, because we can only keep 2 authentication tokens here. I will remove one of them, and I will generate authentication token. It's like a generated security token that I can use on different interfaces, and Docker is using these tokens as a password for Helidon hands-on lab. I will generate a token. What you need to remember only, once token is generated, this is the only moment where you can show or copy the token. If you don't do that, the token is non-available later at all. So this is only at the moment of generation. OCI gives you an ability to copy the token itself. So I copy and store it inside my secret secret file, and it's temporary token. I will remove it after that, so no worry about that. I created my token, so I can right now authenticate myself inside the Docker. So I can log into my Docker. So the first thing I need to do is I need to log in to my endpoint of region name. So through the Docker interface, where is my Docker interface? Okay. I need to log into my Docker repository. So in my case, it was LHR. Let me check. lhr.ocir.io. Username, my default username is okay. So it's my tenancy name / my username. And as a password, I need to paste the authentication token. Login succeeded. I logged in. I logged into the Docker interface, so I'm ready to push. So generally, easier for me to push would be to use exactly this interface. Oh, I think I need to create. Do I need to create a repository first?
Yes.
Yes, I need to first create a repository. So before I'm starting to push, I need to move again into the developer services and container registry. And within that, create a repository, and the repository name should be exactly this one. And I need to make this repository public. So repository is created, like endpoint is created in the repository, but there are no images stored there in the repository. So if I right now go back to, I need to remove it here and make it like a Docker push. Let me check and verify if I need any parameter. No, I don't. So I'm just pushing my Docker image, and my image will become available as in the repository in the OCIR. Okay, so image was pushed. So right now, if I go to my repository interface and I refresh this, I should see that there is one image, version 1.0, that has been pushed, that is like a size 88 megabytes. And if we look into layers, it has been created literally a few seconds ago. Okay, so that somehow finishes the sorry, I can close this. That finishes the lab 4. So in lab 4, we pushed an application, we created application image, we created all necessary infrastructure on OCIR, we authenticated our laptop to push the images to OCIR, and we pushed the image to OCIR. So image with our MicroProfile application is already in Oracle Cloud in the repository. Right now, it's going to be time to instantiate and provision it within Kubernetes as a Verrazano deployment. So run the lab 5 for, we could run lab 5 for to do that. First one we need to do is we need to verify that Verrazano has been properly installed. Verrazano should install several pods. So if we want to verify that Verrazano in the meantime was properly installed, let me check and execute through the kubectl command that Verrazano is properly installed. As I can see, all operators are there. I don't know, maybe Rancher is not there. We'll see later, or maybe Rancher hasn't provisioned properly, but Verrazano generally is installed. And what we should do with that is we should try and take and deploy the Helidon Quick Start MP application. Verrazano is using open application model to describe deployments. Open application model is a specification and standard that describe a component of the application and how applications are constructed. So it especially, in our case, is everything as simple as just one image. But imagine that you have very complex microservices architecture, multiple microservices that needs to deploy it into the proper order, that needs to deploy it in the proper version with the proper amount of instances and wire them to the Istio. That is when this deployment really requires some description. In our case, it's very simple. We are just pointing out to the Verrazano deployment, and we are pointing out to this Helidon image. And we have created for you all YAML files with a component description and application description that are describing this application as an OAM deployment. So what I need to do is just to download. Okay, so let me download this OAM YAML files. Okay. Sorry. There's, oh, I am in the wrong. I think there are two YAML files. One is a component, one is application YAML file. In our case, this application should be super simple because entire application is just one container. But as I said, imagine that it's going to be multiple components that you configure. Then application needs to construct them into one construct. So we need to make some modification in the component file. We need to, because we need to point that the image of our Helidon application need to be downloaded exactly where we just push it. So we need to execute the, sorry, we need to VI the comp file. comp YAML file, and we need to make changes in this section. So instead of this, we need to copy our image URL, our image information. Okay, we made our image public, so anyone can pull the image right now who knows URL. So Verrazano also will be able to pull the image. If the image was private, we would need to create here a secret and create a password for downloading that image. It is of course also possible. So I modify my Helidon component YAML file. Oh, sorry. What I need to do is I need to create a separate namespace where I will be creating my application. Namespace within a Kubernetes cluster. I need to label this Kubernetes namespace that this namespace contains resources that should automatically inject by Kubernetes, should be managed by Kubernetes automatically, and should automatically inject, Verrazano should automatically inject Istio. We are using some labeling mechanism to do that. So since that moment, anything I deploy to that namespace will be automatically managed by Verrazano. So what I need to do is just to create a custom resource with component definition and custom resource with application definition. And Verrazano operators will pick up this custom resources and will construct automatically, will construct automatically application. So to verify that, I probably can check what happens in my namespace, kubectl get pods in my namespace, and my namespace was hello Helidon. And I see hello Helidon deployment has been completed with 2 containers 20 seconds ago. So Verrazano really pulled an image from the repository, pushed created a container based on this image, and automatically plugged all necessary Verrazano observability layers, security layers, Istio traffic management, and everything surrounding that image. So that container is running as a Verrazano managed resource. So we'll be able to observe it in all Verrazano consoles. Okay. So how to verify that Verrazano is running? We need to get the endpoint for our Verrazano application, for our Helidon application. We provide you a script that is able to do that. This is the URL. I can potentially, I believe, to execute it within browser. I'm not sure. Let me try. Privacy error because SSL is not configured. There is a trick to solve it. If you click advanced, it's enough to right now type this is unsafe. And yeah, and we got access to our service that returned this table of greetings. Some encoding is probably not automatically set up, but this is fine. So I was able to execute it from that. So Helidon service is really running behind that. I will remove that. We can try to execute it also over curl. And it return our greetings. So service is running really. Service is responding. We executed it twice. I can try to remind you. So later, whenever we'll be looking for logs, you should see two instances of executions. So we executed it twice. Application is up. Application is running. We could right now try to check and go to the lab 6. Check on Verrazano how to monitor the application. What are the Verrazano capabilities to monitor our application? So let's move to lab 6. I will minimize that. We will open up Verrazano console. There is a command that gives us access to all Verrazano consoles. So I will execute that. It should give us URLs to all Verrazano consoles that are configured. So first console that we'll be exploring today is a Verrazano console. Again, first time when you reach it and SSL is not configured, the Chrome is trying not to let you in. But if you click advanced and you type here, this is unsafe, then Chrome should let you in. Oh, why it didn't let me in? This is unsafe. Okay. Now, username to Verrazano console is a Verrazano user. We describe this trick here as well. So if you open up in the Chrome and you click advanced, it is just enough to type this is unsafe without any space anywhere, and it should allow you to proceed to your code. The same we will do with all other consoles. Verrazano password to the console is stored as a secret. We show you how to decode the password from a secret. So password is here. That's gonna be our password. And when I log into Verrazano console, I use that password to get access to. And you see that Verrazano is giving you access to several consoles. As I see, Rancher is still not installed. Oh, I don't know. Okay, but we have only one application configured. We can check and verify this Helidon application. And when I look into the console, into the component definition, and the specification, I can see that this application is based on the image that I was just created. So that component only runs single container and runs on port 8080 and given access to applications. So this is more or less how you can prove that Verrazano is managing this application, we will try to get an access also on another console. We'll try to review how this application is automatically plugged to Grafana. We didn't do any manual configuration. We will basically try to see how Verrazano automatically plugged our application to Grafana. Again, this is first time I'm reaching Grafana, so I need to make this unsafe. Okay. When I search, my application is a Helidon application. So if I look for Helidon monitoring dashboard, oh, I see that there is a service that automatically has been configured, has been started 5 minutes ago. It is up. There are some threads that are running. There are some memory that is occupied. And that generally gives me access to my Grafana dashboard over my Helidon application. If your configuration, if your cluster would consist other services like Spring Boot services or I don't know, other type of containers, or even WebLogic or Coherence, automatically all that workload will be configured into the proper Grafana dashboard, and you are able to automatically get look into monitoring information from your Grafana dashboard. I'm not so this is about Grafana. We will be also exploring OpenSearch. OpenSearch is like a fork from ELK. ELK, Elasticsearch, recently changed the licensing policy, so vendors like Verrazano cannot embed ELK. So we are using an open source fork for log management. So OpenSearch is being used to OpenSearch dashboard is being used to get a dashboard for log entries. So let me open the OpenSearch dashboard. Again, we need to use for a first time trick with this is unsafe. That should log me to the open dashboard. And what we need to do is we need to create index pattern. And we will be using timestamp. Is it correct?
You just go back to the main screen.
Thank you. No, here.
Yeah. You can see that there is an application Helidon.
Yes.
Yeah, you can. Yeah, you need to just copy and just paste it.
Oh, okay. Thanks. Here.
Yep.
Okay. Create index pattern. And I'm a little bit lost. Sorry for that.
You just need to click on the discover icon again. Yeah.
Okay, sorry.
Yes.
Oh, yeah. So you see that we executed it twice. And if you help requested, is twice in the log. So I have executed it twice, and Verrazano was able to catch the log. Probably if I execute it once again, and refresh, you will see one more entry in the log management system. And also open dashboard that is configured as a part of Verrazano automatically will grab all logs from my Helidon application. So if I refresh it now, okay, I should see another entry of help requested. It's a log entry that is associated with our all greetings RESTful endpoint. Okay, and the last one that I would like to demonstrate today during our workshop is exploring Prometheus. If you come back to the main page and click on the Prometheus, and again, this is unsafe trick. Get the collect information about custom metrics. Where was it? Should I copy paste Ankit, or it's enough for me to
just search for the Ankit here?
Ankit?
Yeah, the first one.
Okay, this one.
Yep.
Okay, and execute. That we see here probably that it has been executed. There is a counter somewhere.
It is in the right side.
Oh, there is a counter, but we executed it 3 times. Is it correct?
Yes, and you can also show to the graph also.
Yes, and we executed it 3 times. If I execute it once again, you should see that Prometheus that is associated with that should start showing the fourth execution. Okay, come on. You
can again click on the execute to refresh.
To force a refreshment. Okay, you can see the 4th execution here. So as you see, all those observability layers are automatically attached to your microservice application. So we show you during your lab full end-to-end life cycle of creation, building a simple dummy MicroProfile application, plugging it as a Docker container, and making it as a part of the Verrazano deployment. And we show you and demonstrate it to you that automatically, once it's become Verrazano deployment, it is visible on all observability layers, and the Verrazano entire monitoring is automatically enabled, and you don't need to configure anything as a part of your deployment to configure it with Grafana, with OpenSearch, with Prometheus, with Istio. Everything is delivered to you out of the box. We have, as I completed entire labs. I'm not sure if there are any more questions. Let me check there are no questions on Slack, and let me check the question on a chat. So generally, I understand that it might be quite difficult to follow the labs and to look into the demo. So I'm 100% aware that you might be stuck somewhere. If you would like our assistant, mine or Ankit, we'd be more than happy to assist you with this lab execution in your environment, even after the event is over. So please reach us over the Slack. We are on a Slack. We are looking to assist you and help you with these labs. And If there are no more questions, Tara, that's all from my side for today.
Great, thank you so much. Just a couple quick things before we go. If you enjoyed today's session, we'd like to invite you to upcoming events that we've got going on. So I'm just going to post those in the chat now, a couple links, upcoming events. And then, of course, we'd also like to know how you found today's session. Give us any feedback on the lab or anything that you'd like to see from us going forward. So with that, I will conclude the session for today. Thank you again, everyone, for joining us, and we hope you have a great rest of the day and to see you again next time.